All right, so welcome back to everyone. A very warm welcome to all of you, the future doctors, the NEET aspirants. So, guys, in today's session, we are going to begin with the chapter of kinematics, that is motion in a straight line. Okay. So, in the last session, we have completed the units and measurement. So this chapter has been completed on this channel, your very own channel, Need Success Simplified. Okay. And I'm your very own Dr. Shankar Sir, your physics educator. And we are starting with the new chapter today, that is motion in a straight line. Okay. Okay, so previous to this chapter, we have completed the chapter of units and measurement in complete context, right? We have completed this chapter. We have completed this chapter completely. And I am hoping that you have enjoyed our journey of physics that we have done till now. Okay, you have enjoyed the journey of physics till now. And guys, in this session, I'll be starting with a new chapter. That is the chapter of motion in one dimension. That is motion in 1D. Okay. Okay, so briefly, I'll be introducing myself. So my name is Dr. Shankar Sir. I have completed PhD and Masters from Indian Institute of Technology, Roorkee. Okay, and there are some more credentials. Let's move to the session. So in this session, I'll be starting with the part of the kinematics. Okay, so it is one of the biggest portion in the journey of the physics that we have started. Okay, and in this I'll be starting with firstly the motion in straight line, that is motion in 1D. Okay, so basically when I say about this kinematics part, so as per the NCRT, your chapter 3 and chapter 4, that is motion in a straight line and motion in a plane, both chapters are somewhat related to this kinematics only, and this is also prerequisite to start the dynamics part. Okay, so what is this dynamics part? So when we start with the law of motion, so basically when we talk about forces, that is the part in which we say that the dynamic is start. Okay, now to understand the dynamics, we must firstly be understanding the part of kinematics. So particularly I'll be talking about the motion in 1D. But before that, what is kinematics? So kinematics, when I talk about kinematics, so what is the meaning of this kine? Okay, Kine. So the meaning of kine is motion. Okay, so the live student can respond to me in the chat if I am perfectly audible and visible to them. So this kine means that motion. And what is the meaning of this matics? What is the motion of the matics? What is the meaning of this matics? So matics means that mathematics. Okay, what does that mean? So it means mathematics. So what do we mean by kinematics? So it is the mathematics of motion. It is basically the mathematics of motion, right? Okay, so when we talk about the mathematics of motion, that is what we call as the kinematics. Okay, okay. So basically, in the part of kinematics, what we intend to do is, so basically, we want to talk here about the motion in one dimension. Okay, so motion in one dimension means that motion in a straight line, or you can say rectilinear motion. Okay, so this makes your chapter number 3 as per the NCRT. So motion in a straight line. Okay, so we can call it a straight line motion, or you can call it popularly rectilinear motion. Okay, so in this part, when we talk about the motion in one dimension, we talk about the rectilinear motion. Okay, then we have motion in 2D. Okay, motion in two dimension, like circular motion. Okay, this is going to what we are going to see in the next chapter when we are starting motion in a plane. Okay, we'll be talking about the vectors, their addition, subtraction, multiplication. Okay, laws related to the vectors. All we are going to talk in the next chapter, that is chapter number 4. Okay, motion in 2D like this. Okay, so these are the two-dimensional motion. Then we'll talk about the motion in 3D. Okay, to some extent, not much. like motion like this. Okay, previously there used to be a program coming on the Doordarshan, that is Shaktiman. So the motion lap of the Shaktiman type motion. Are you getting my point? So that is three-dimensional motion. Okay, like the motion of molecules. If you are following the chemistry also, so motion of molecules that we see in chemistry, so that is sort of a three-dimensional motion. Okay, but in the syllabus, we mostly need to talk about the one-dimensional and two-dimensional motion, right? So when I talk about this motion, so basically, what are the variables? What are the the physical quantities involved in motion that we need to talk about? Okay, so what are the different things that in the motion we need to talk about? So we need to talk about the distance. Okay, we need to talk about the displacement. Then we need to talk about the speed, right? And we need to talk about the velocity. Okay, we will be talking about the acceleration. Okay, acceleration, and we shall also be talking about one thing, that is jerk, to some extent. So what is the jerk? Okay, so see, when acceleration changes with respect to time, we call it a jerk. So see, we all know when displacement changes, velocity happens. When distance changes, speed happens. When a speed and velocity changes, there is acceleration happens. But what if acceleration changes with time? So if at all acceleration is changing with respect to time in any of the cases, that means it is going to feel some jerk. Okay. So jerk is also a term that is used in kinematics. We might have not heard about it before, but it is there. We'll talk about it to some extent. Okay. Now, guys, before I begin with the chapter, okay, so in this chapter there will be a little bit of vector requirement, very small. Okay, so I'll be completing the vector in complete context in the next chapter, right? You have nothing to worry about. So I'll be, if required, when as and when required, when we'll be requiring the concept of the vector. Okay, I'll be giving you some glimpse of it, and in the next chapter I'll be completing it through complete way. Okay, I could have done one thing. I could have started the vectors first. Okay, but why I didn't did so? Because I want to flow with the chapters, with the flow of the chapter, with the sequence of the chapter, which are given as per the NCERT and as per the syllabus of the NEET, right? That is why I have picked up this chapter, and after that, as we follow in our normal syllabus, we do that. So, little bit about the scalar vector we already know, na? Okay. So let's start with the session. Let's start with the motion in one dimension. Motion in a straight line. So this is the first part of the kinematics, that is mathematics of motion. Also, in when we talk about the kinematics, basically we don't talk about the forces that cause the motion, right? See, we all know that every motion is obviously caused by some force. Okay, but when we talk about the part of kinematics, when we are talking in the part of kinematics, we won't talk about the forces which cause the motion. And the same flow goes when we go to the fluid part also, in any part. Like in fluid also, when we talk about the kinematics, we talk about the continuity equation. Okay, where we don't talk about the forces. And later on, when in the dynamics, when we also consider forces, dynamics means forces and motion both. The study, when we are studying the motion with the forces, that is dynamics part, where all the law of forces are involved, laws of vectors are involved. Okay, and in the kinematics part, we do not consider the forces which causing this motion. That is the basic difference. Okay. Okay, and see, this is prerequisite to go to the dynamics part. Okay, so once you understand this, you will be able to understand the next chapter also, Newton's law of motion, very well. Okay, so why sir we are not getting this? So F is equal to ma, we all know na. Force is equal to mass into acceleration. So from where we are going to get the acceleration? We are going to get the acceleration from this very chapter of kinematics, and that acceleration that we got, we can use in the dynamics part. Okay, now please understand this. Let's start with the basics, and we'll now And we have to be very objective also. I want to finish this part very quickly. So there are two things. One is distance and one is displacement. So how would you say that what is the difference between distance and the displacement? I hope that we have heard both of these terms, na? Right? So we have heard about the distance, we have heard about the displacement. So what is the distance? So basically it is a scalar quantity. I can say it is a scalar quantity, right? And this is a vector quantity. It is a vector quantity. So what is a scalar quantity and what is vector quantity? So see, please understand this. So a scalar is something, a scalar quantity is something which depends upon the magnitude only. Which depends only upon the magnitude. You have nothing to do with the direction. Okay. Whereas the vector quantity is something which requires magnitude as well as direction. Okay. And merely, I'll explain on this thing when I go to the scalar and vector part. I'll give you complete understanding of it. But time being, if we say broadly, we say that a scalar is something which depends only on magnitude. Okay, this vector is something which depends upon both magnitude and direction. Okay, but there is more to it. See, the quantities which are depending upon the direction also cannot be the vector. Okay, like you see, stress is not a vector. Electric current is not a vector. Okay, pressure is not a vector. So there are quantities which do have directions, but they don't fall into the category of vector. They can be scalar, they can be, there is one more type of quantity, that is tensor. Okay, so they can be scalar, they can be tensor. Are you getting my point? So for time being, we are having this loose understanding minded, that is not a complete understanding, but broadly we can say that a scalar, which is something depends upon the magnitude only, and displacement depends upon the direction also. Okay, so it depends upon the both direction and distance. So what is distance, what is displacement? So we all know it's more or less. So displacement is the shortest distance. It is the shortest distance bit from shortest distance from initial to final position. It is the shortest distance from the initial to final position. So what does that mean? So we have some initial position. We started our journey. We started moving. We have started covering some, lengths. Okay, from some initial point, and we have reached the final point. So the shortest distance, remember, is the displacement of something. Shorter distance is what? Shortest distance is the displacement of something. Just give me a moment. Yeah, extremely sorry. A bug is there. What's the name? Bug. B. So if it would have bitten me, my mouth goes like this, no? Okay. So that is why I had to take care of it. Okay. Now please understand this. Okay, please understand this. So what I was saying that displacement is the shortest distance from the initial to final position. Are you getting my point? It is the shortest distance from the initial to the final position. Okay, so someone has started some journey. Okay, now please understand this. See, very simple. We all know it. So let's suppose you are in Lucknow. Okay, and you want to go to Delhi. Okay, you want to go to Delhi. So you can go by any way. Na? You can first go to Jaipur, then you can go to, Chandigarh, and then you can come to this Delhi place. Okay, Delhi place. So what is distance? Distance is what is the actual you have traveled, the actual length you have traveled. Okay, so you went from Lucknow to Jaipur, let's suppose. This is, I don't know actually. So this is somewhere 500 kilometer. From Jaipur to Chandigarh, it is 800 kilometer. And from Chandigarh to Delhi, it is 200 kilometer. So basically, what is the distance you have covered? So you have covered the distance, see. So distance is the actual travel that you have done. Distance is what? It is the actual travel that you have done from one point to the other point. Okay. So for example, if in this case I talk about the distance, so distance is going to be, sir, 500 firstly we went, then 800 firstly we went, then 200 lastly we went. So it is going to be equal to 1500 kilometers. So what is the distance we have traveled? We have traveled 1500 kilometers. But what is the displacement? So displacement is the shortest distance. Okay. It is the shortest distance between the initial point to the final point. Okay, so from Lucknow to Delhi, if you follow the shortest path, the shortest path is become the displacement. Okay, displacement. Did you get it? Okay, now you can have multiple explanation to this. So, like for example, we have 2 points A and B. Okay, now there can be infinite ways to reach from A to B, right? You can go like this, you can go like this, you can go like this. Firstly, you go like this. So all these are what? All these are our distances. What is the actual length you have followed? Okay, okay, but the displacement is like the shortest distance. Okay, so between A and B, what is the shortest distance? This is the shortest distance. So this is the displacement. This is the displacement, right? Okay, very, very simple. No, we all know it. The displacement is the shortest distance. It is a vector quantity. Okay, distance is a scalar quantity. It depends only upon the magnitude. You have nothing to do with the direction. Okay, but displacement is a vector. It has to do with the direction as well. Okay, okay. So from initial to final point, what is the actual path you have followed? That refers to the distance. And what is the shortest path that could have been followed? Okay, if followed or not, that is not our concern. Okay, if from initial to final, what is the actual distance? What is the actual followed path refers to the distance, and what is the shortest path? Okay, no matter if it is actually followed or not. Okay, that will be the displacement. So if I ask you, displacement is also a sort of distance only. No, but it is just the shortest distance. So if I ask you, like, what is the difference between distance and displacement? Now, which of the following would be correct? Distance is greater than displacement. Okay. Distance is equal to displacement. It is equal to displacement. Then we have the distance. It is greater than displacement. It is greater than displacement or equal to displacement, and distance is less than displacement. So if I ask you these four options, out of these four options, which one you would be choosing? The live student can tell me, beta. The live student can tell me. See, I'm not going to give much time to this distance displacement thing. I hope many of us are knowing all these things. Okay. We are here to quickly complete the syllabus, not to waste the time, right? Okay. I have seen people teaching this thing like in 2 hours, 1 hour, 2 hours. They give you hundreds of examples. But I think this much is sufficient, no, yeah. Right. So what is going to happen? So distance is greater than displacement. This is true thing. Okay. See, distance can be greater than displacement. See, like this, wherever. So obviously distance can be greater than displacement. Distance can also be equal to displacement because displacement is the shortest distance only. So from one point to another point, if actual path followed is the shortest one, so the distance and displacement are going to become equal. Then we have distance greater than equal to displacement. So this is also correct. Distance can be equal to displacement. It can be greater than displacement. Both are true. Distance can be is less than displacement. So this can never happen. Na? This can never happen because the shortest distance. What is displacement? The displacement is the shortest distance. So when displacement is the shortest distance, guys, when displacement is the shortest distance, okay, when displacement is the shortest distance, there cannot be any distance which is shorter than the displacement, obviously. So distance is less than displacement. This is never going to happen, right? Now, please understand this. Let's suppose we have 2 points A and B. Okay, we have 2 points A and B, and to reach A and B, we moved in a semicircular path. Okay, semicircular path, and this is 2R. This is 2R. Okay, so all I may say, a person, I write something, a person moves from A to B, A to B in a semicircle, in a semicircle of radius R, semicircle of radius R. Okay, so a person is moved from A to B in the semicircle path of the radius R. So what is the distance and what is the displacement in this case? How do you say? So this is a semicircle. So you will say the very, very easy. Distance is the actual path followed. So what is the actual path followed by him? So sir, he started from A and followed the semicircular path. So the distance traveled by him is pi r. Okay, because what is the circumference or what is the perimeter of the whole circle? Sir, the perimeter of the whole circle is 2 pi r. Okay, so the perimeter of the semicircle is going to be pi r. Okay, so the distance is going to be pi into r. So what is going to be the displacement? So displacement is the shortest length or shortest distance between A and B. So what is the shortest distance in between A and B? So sir, this is the shortest, obviously. So it is what? Sir, it is obviously, this is refers to the diameter. So this is obviously sir 2r. Okay. 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 So this is how we can get the displacement and the distance. Let's solve some more question. Okay. Let's suppose we are having a circle like this, and this is point A. Okay, on the centroidal axis, and we have the point B here. Okay. So from A to B, the actual path followed is from A to B, from A to B, and you see from A to B, and this is a quarter of circle. A to B is 1 by 4th of circle, and you can consider the radius of circle as R. Okay, R is the radius of this circle. Radius of circle. Okay. Now, how you are going to get the displacement? Get me the displacement here. What is going to be the displacement? Very, very simple, sir. So, what is the distance? The distance is A to B. Okay. Quarter of a circle. Okay. So, 2 pi r by 4, that is pi by 2r. Right? Pi by 2r. But what is the displacement? So, displacement is the shortest distance from A to B. Okay, so for finding the shortest distance between A to B, what I can do? So I can join this AB. So when I join this AB, this is going to be the shortest distance. So this is the center. So this doesn't look like the center. So this is the center only. Da. This is the quarter circle. So this has to be a center. Pardon my skills of drawing. Okay. So this is R, and this is also R. Right. This is also R. Right. Okay. Okay, so what is going to be this AB? So by Pythagoras theorem, we can apply. So what is the displacement? That is the length of AB. And see, it is a vector, so I can write this vector. This is the standard way of representing the vector, right? Displacement is the vector. Okay, but we are, more concerned with the magnitude. Okay. Okay, so vector AB is having the magnitude, so we can get the Pythagoras theorem. So it will become root 2 of r square, isn't it? Sir, we know the Pythagoras theorem, right? Or do we need to tell you the Pythagoras theorem here? What do you say? What do you say? No, sir, absolutely fine. AB is the hypotenuse, base, and perpendicular are R and R. So we know hypotenuse square is equal to base square plus perpendicular square. So I hope it is fine to everyone, right? Now we can have one more. Oh my goodness, my circle is not looking like the circle, it looks like the egg. Right? Live student may tell me. So let's suppose we started from A and then we go to B, okay, in a semicircular path. So what is going to be the displacement? So you would say, sir, don't waste our time. It is going to be 2r only. Okay. If I say I start with A and reaches back to A, what is going to be the displacement? If I start at A and then come back to A, what is going to be the displacement? It is going to be 0. But will there be any distance? Yes, sir. The distance will be 2 pi r. Okay. Okay. Are you getting my point? So see, simply, so see, we started in east. Let's suppose we goes 4 meter in the east. Okay. Then we come back 4 meter in the west. Okay. So what is the displacement? What is the displacement? Displacement is 0 because you started at this point. So those both are overlapping each other, na? So you started from here and you come back to here. Okay, so that is going to be the displacement is going to be the 0. It is going to be the 0. Are you getting my point? Okay, this is going to be 0. Right? Okay. Okay. But the distance will be 8. Okay, so if we move 4 meter east, then come back 4 meter west, the displacement is going to be 0, but the distance will be 8 meters. Okay. Okay, now please understand it. So this is going to be 4 meter. So we can solve some more questions. Let's see. So let's suppose we have another. So let's suppose we have this A point. This is your initial point. B is your final point, and the angle between them is 120. Okay, and we followed the path. Actual path followed is AB. The actual path followed is AB. Okay. Actual path followed is AB. So how we are going to do it? Please answer me. So we need to find the displacement. Okay, R radius is R. R is the radius. Okay, and we followed A to B. We goes from A and ends up at B, and we need to find the displacement. Sure, please go for it. Let's see if we can do it or not. Please try to do it. I'm very sure we can do it. No problem at all. Please go for it. Please go for it. From A to B. From A to B. How we can do it? How we can find the displacement? So here you can use some geometry. Here you can use the vector thing. Whatever you want, you can do. Okay. So sir, obviously the displacement is going to be. So the live students can respond to me if any doubts are there. Yeah. Very good afternoon. So basically, what is going to be the displacement? So it is going to be the shortest distance between A and B. So see, if you can apply geometry, you can do so. If you don't want to apply geometry, you can go for the way of vector, whichever suits you. Okay, so this is R, this is R, this is R, this is R. Okay, okay. So what we can do? Let's suppose this is D. So how can we find this D? Okay, how can so we can use this? So if this is 120 and this is D, so obviously this is going to be 30 degree and this is going to be 30 degree. Sir, how come, sir? Sir, जब हम छोटे बच्चे थे, when we were little kids, we have studied one concept of isosceles triangles. Okay, so this is an isosceles triangle. If two sides are equal, so when two sides are equal, these two angles are also equal. Now one angle is 120, so we know that the sum of angles of a triangle is 180 degrees. So one angle is 120 degrees. The remaining two angle must be 30 and 30 only. 60 is rational, so 60 divided into 2. So you can use the sine rule. That sir, we don't know the sine rule. We'll derive the sine rule, don't worry. But you must know the sine rule. Okay, so what is the sine rule? I'll just try to tell you sine rule. See, sir, why you are telling us the sine rule? Because see, in geometrically you can use it quite well. Okay, so geometrically it is very very helpful and it will help you find solution to many other, because this is more of geometry now. This is more of geometry. Okay, either you can go for the way of vector. The sine rule is also derived from the way of vector only. So now please understand this. If this is alpha, this is beta, and this is gamma. This is gamma, and we have this. Let's suppose the length is x. Now you would say that this is something from chapter 4. But don't worry, it's a very small thing, na? X, Y, Z. See, if we are going to go in a very conventional way, I'll tell you, we'll not be able to complete the syllabus, and we have to. Okay, we are trying. Okay, so sometimes some improvisation, some adjustment will be done. Now in this case, see how it is very very simple. See, x upon what are the remaining side, y and z. So what is the angle opposite to x? So it is gamma. Okay. So see, you picked up one side, then you pick the angle between the other two sides. Okay. So once you have picked one side, the angle that is to be picked is the angle between the remaining two sides. So x you have picked, the angle between the remaining two sides is gamma. So it will become x by sine gamma. Then y. So you have picked y. Now what are the remaining two sides? So it is x and z. So it will become sine alpha. And then you have picked z. So what is the angle opposite to it? So beta. So it will become sine beta. It will become sine beta. Now you can apply this in this triangle. So you see r upon sine 30, is equal to d upon sine 120, d upon sine 120, right? See, r upon 30, d upon sine 120. So d is equal to r sine 30 upon sine 20. Sine 30 upon sine 120. So sine 30 upon 120 कितना हो गया? So it is going to be root 3 of r. I hope it is fine to everyone. Okay. Okay. Please answer me. Please answer me. The live student. Please answer me. Is it fine or not? Live student guys. Okay. So we know this calculation. Na? So sine 90 plus theta is equal to cos theta. All this you know na. So sine 130 is cos 30. Sine 30 is 1 by 2. Cos 30 is root 3 by 2. Okay. 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 So from here you can get this. Right? Please answer me. I am waiting for some students. So if you don't know this sine thing, cos thing, you can tell me in the comments. Na? Are you getting my point? Are you getting my point? Okay. Oh my goodness. Just one moment. Huh? So that is why I was thinking there is some mistake. So see, this is r sine 120. Nah, sorry, my bad. Sine 120 upon sine 30. So this is then going to become root 3 by r. Right? My bad. Okay. Okay. So what is the displacement that is going to be here? So it is going to be root 3 of r. I hope it is fine to everyone. Yeah. So yeah. Right. Now there could be another way to solve this. There is one more way to solve it through vector. If you like this way, then you can go by this way. And also see guys, if you want that, sir, I'll tell you all the trigonometric relations like I have used here. Sine 90 plus theta is cos theta, because I am assuming that you know all these things. Okay. But if you don't know, I can take one section on that also if you want. Okay. Otherwise, I'll move with the physics. Okay. Because these things are very much required. See, in physics, you must be handy with your trigonometric relation. Some differentiation will be required. I'll be telling you what differentiation will be required. To whatever extent you need the differentiation, I'll be telling you in the next session mostly. If we complete whatever is the target in today's session. Okay. So there could be one more way if you want to generalize it. If you want to generalize it, so let's suppose on circle there is one point. So this A and B on this circle could be on any place now. This A and B like these. So it can be at any place, right? There can be, okay, so like we can have any angle and any position of this A and B, right? So this is A. Let's suppose this is B. So what I do, this is R, this is R. Let me generalize it. So this is theta and this is B. This is the displacement. Okay, so these questions are getting asked a lot. Na? So like on circle, we started at some point, then we moved towards some point. Okay, okay, following this angle. What is the displacement? So now in each of the case, see, you can apply this law, the sine law also, if you find it more comfortable, or otherwise if you want to develop one formula of it, because I have seen many students say, "Sir, just make us a formula, we are good to go." So basically if I use the vector, let me use the vector. So this is one vector. Now we know from the head tail rule, from this vector I need to start another vector. So let me call it r1, vector r1. Why a vector r1? So these two are the same in magnitude. This vector and this vector are same in magnitude. So no, they are not same in magnitude. They are same in magnitude, but they are different in direction. So when we go to the vector part, now I'll tell you, if two vectors, even they are same in magnitude, they are not the same vectors. If they are having different direction, same vectors are the ones which have the same magnitude and the same direction. Okay. So this is going to be R1. So head tail method. So from the end of one vector, we go for the another vector. Okay. And then we have the resultant. Okay. So how we get the resultant? So resultant is going to be like this from the tail of the first vector to the head of the last vector. So from here, can we write R1 plus D is equal to R2, right? If you go by the phenomena of vector, R1 plus D is equal to R2. So R2 is going to be, or D is going to be, R2 vector minus R1 vector. So sir, here two vectors are subtracted. Okay, guys, vectors are never subtracted. There is nothing like vector subtraction. This is confusion. Sir, this is written in NCERT. I mean, don't trust me. I'll prove it. Vectors are never subtracted. They are always added. Are you getting my point? So here I can write this vector like this. So R2 plus minus R1. Okay, minus R1. Now see, this is two vector addition. So when we go to the vector, we'll see the law of parallelogram of vectors. Okay, the law of parallelogram of vector addition. So from there you can get the magnitude of this D, that is going to be, so what is R2, R1? So in this parallelogram law, we will be using the magnitude only. So what is the magnitude of this R2? So it is R square. What is the magnitude of this minus R1? So it is minus R. So minus R squared will become minus R. And then plus R1, R2. So it is plus R minus R, and the angle between these two vectors. Sir, we are not getting it at all. Don't worry. If you are not getting it at all, don't worry. We'll go to the vector part after this chapter, and then we'll be using this. So already I have solved this equation. This way I'm going to tell you, I'm telling you because I want to develop one formula. Okay. So those who are more interested in memorizing the formula, they can memorize this formula. Many students do this way. Are you getting my point? That is why I am doing. If you are not able to get it, there's nothing wrong. Don't worry about it. Okay. So this will become see, 2 times r square, and this is going to be minus r square cos theta, so this is going to become, okay, this is going to become, sorry, this is 2 also, na? law of parallelogram of vectors addition. So it is p1 square plus p2 square minus 2 p1 p2 cos theta, right? So 2 I missed, so this is 2 square. So can I write it like this, 2r, because we can take 2r square common. So 2r square. So I have taken the root thing out. So it will become root 2, r square will become r, and this will be left with root 1 minus cos theta. Or it is getting very complicated now. I'll just write like this. Don't worry. So can we write like this? 2r square 1 minus cos theta. 1 minus cos theta. Okay. Now from here, see, you must be knowing few formulas. So cos 2 theta is equal to cos 2 theta is equal to 1 minus 2 sine square theta. Okay. 1 minus 2 sine square theta. So from here we can write sine square theta. Okay, sine square theta is equal to 1 minus cos 2 theta by 2, right? Can we write like that? Okay, by 2. So from here, can I write this as 2 sine square theta? See, some trigonometry will be involved. So 2 sine square theta by 2, if this is by 2, and this will become 1 minus cos theta. 1 minus cos theta. Do you agree to it? Okay. So 1 minus cos theta is 2 sine square theta by 2. 1 minus cos theta becomes 2 sine square theta by 2. So this is going to see simple mathematics. Don't be afraid of this much mathematics yet. Sir, we are NEET aspirants, sir. We are good in biology, sir. You are started this mathematics. Don't worry, don't worry. I'll just give you the formula. So this will become 2 sine square theta by 2. So if we take the root sign out, it will become 2r sine theta by 2. So if the case, so this is the standard formula. This is the standard formula. Now in any case, if you see, this is for those students who are good at memorizing the formula. If you are not good at it, just leave it. You can go by the geometry, basic geometry. So we know the why to complicate the things here. We know the basic understanding like this we can do if we are good at geometry, right? Simple sign rule you can apply, or any other way of geometry if you want. But if you want to use the direct formula, you can use it. So in this case of circle, see, this is very much asked question. In the case of circle, so we started it from some point, then we moved to some point. What is the displacement? This is a very frequently asked question. So for it, we have developed this formula, d is equal to 2r sine theta by 2. So you can do by this formula also. So what is the displacement here? So a to b, what is the r? R is the radius, and sine theta. Theta is 120, so this is going to become sine 60. Sine 60 is root 3 by 2, so it will become root 3r. Similarly here, if you want to do, so what is this angle? So obviously this is 90 degree. This is 90 degrees. So d is equal to 2r sine theta by 2. Okay. So sine 45. Sine 45 is 1 by root 2. So 2 by root 2, that is root 2 of r. So why I have written r square here? This is root 2 of r, not r square. We have taken the Pythagoras theorem, then we have done. Na? So many mistakes are happening with me today. Okay. I'm sorry for that. This is not r square, this is root 2 of r. So please make the necessary correction. Yeah. So this, and I can think that you can, so if we put sine theta by 2, this will become 1 by root 2. So obviously we are getting root 2 of r, right? Now in this case, this has become 180. 180, so again you put this formula 2r sine theta by 2. So theta is 180 by 2, that is 90. You are again getting the same answer. So if you memorize the formula, you don't have to use any brain. You can directly apply this formula. But I recommend why to use this formula now. We can go by the simple geometry. Or if at all this formula is required, anyhow we are going to learn the vector. Okay. So please explain us again this thing. I'll just explain. So this is R1, D, and R2. Okay. So see there are, if you want to go with the vector, so this is head and tail method of the vector. Those who are knowing it, and those who are not knowing it, don't worry at all. I'll be starting the next chapter very, very quickly. Okay, so this first vector, so head tail law says that whenever you are adding the vectors, Okay, whenever you are adding the vectors, you start with one vector. Then from the head of the first vector, you start with the tail of the other vector, the next vector. Okay, and your resultant will be the starting from the tail of the first to the head of. You join the tail of the first to head of the last vector. That is going to be your resultant. Okay. Okay. Then we use the simple resultant thing. Resultant is going to be the addition of all the vectors. So R1 plus D is equal to R2. So R2 D we wanted to find. So D is R2 minus R1 and R2 minus R1. Then we move with the law of parallelogram of vector addition. Okay, so from law of parallelogram of vector addition, if two vectors are at a distance of, so this is the statement of like this. Okay, so this R1 and R2, these two are having, so two vectors added. So this is subtraction. There is nothing like subtraction. So two vectors when added and their angle between them is theta. So the resultant is given by under root first vector square plus second vector square plus 2 times first vector second vector into cos of angle between them. Right? Okay. This is what we are going to do. So from here we just have done some calculation. Then we wanted to simplify. This formula is also good to go. Okay, but we want to have it further simplified. So when we want to have it further simplified, what we can do? We can write, use some trigonometric relation. So cos 2 theta is equal to 1 minus 2 cos sine square theta, or 2 cos square theta minus 1, both are the same thing, right? Okay, very good. Now let's do with the another question. Let's move to one more question. Let's try this one, very interesting. Very interesting question. Let's try it. Let's try this question. I'm quite sure we can do it. बहुत simple है. Very, very simple question. And very frequently asked question, very conceptual question. Let's try to do that. I'm very sure we can do it. करिए please कोशिश करिए. Let's try to do that. The live student can respond to me. Sir, how can we do this? So a wheel of radius r is rolling on the road. What will be the displacement of a point P in half rotation of wheel on the road? Very interesting. Very interesting. So let's suppose we have a wheel. Okay. Okay. And this wheel is having this point P. This wheel is having this point P over here. Okay. Actually, in this question, the figure was also there. So this P point is here. Okay. And this wheel is rolling on the road. What will be the displacement of a point P in half rotation of wheel on the road? So this is rotated by half. This is rotated by half. Now, what will be the final position of this P after half a rotation? So what will be the final position? So it is rolling. Rolling means that it is moving forward also and it is rotating also. So rolling is sort of, rolling is sort of, you see, combination of the linear and rotational motion. So when something like the tire, if you roll it on the road, so what happens? It is sliding also. That is, it is having some rectilinear motion also. It is having some rotation also. Now, when it rotates by half of rotation, it will be displaced. It will move forward. It would have moved forward also, and this point also have changed. So obviously, this point in half the rotation will reach this top point. Okay, will reach this top point, and what is it, sir? How much distance? This from here to here, it will be pi r because it has taken the half the rotation now, obviously. So if one complete rotation it would have taken, it would have forwarded by 2 pi r distance. Now since it is rotated by a distance of half rotation, since it is rotated by half a rotation only, so that means that it is going to cover the distance of pi r, okay, okay, in the linear direction. So this is pi r. Now many students give the answer to this question as pi r only. So this is the shortest distance. No, sir, this is not the shortest distance. Shortest distance is this. If you join this P, this is P, this is initial P, this is final P. So this is going to be your, this is going to be your what? This is going to be your shortest distance. See, this is going to be your displacement. Displacement is what, guys? Displacement is the shortest distance from initial point to the final position. So initial position is P, it is on the ground. Now it has taken half a rotation. Now it has taken half a rotation. Now when it has taken half a rotation, now when it has taken half a rotation, it is going to reach to this place. Okay, or this position will be this. Now when it is having this position, when it is having this position, what is the shortest distance between these two? So the shortest distance between the initial position of P and final position of P will be when you are joining them right away straightly. There can be any other, you think there can be any other shortest distance. Okay, so you join them is right away. That is going to be your shortest distance. So this is pi r, this is going to be 2r, this is going to be the 2r. Okay, okay, so pi r and 2r. So what is going to be happening? So this is the displacement. So the displacement is going to be how much? So again, we can apply the Pythagoras theorem. So let's call it d. So sir, it will be pi r square plus 2r square. Okay, now you can have it calculated. Whatever it is going to get, you are every time I write and my face covers what I am writing. So it will become pi r square, okay, plus 2r square. So if you calculate it, what are you going to get? What you are going to get? So whatever you are going to get, you can have it with you, right? Okay, yes or no? Any live student, if you have any doubt to me, please ask me. Okay. Now, if at all it is asked that what is the direction of this displacement? See, displacement is a vector quantity. Vector is something we loosely have understood. It depends upon the magnitude and direction. Why you always say some we loosely have understood? This is the thing that we know from like when we started this physics thing. So vector is something that depends upon the direction. This is half truth. As I said, there are many quantities which do have direction, but they are not vectors. Like electric current is not a vector, pressure is not a vector. Okay, okay, stress is not a vector. Okay, so there they can be tensor, they can be tensor. What is tensor? Sir? We never have heard of it. Don't worry, I'll give you some glimpses of it. Don't. Some quantities are tensor. Okay, so see magnitude, direction, and the orientation of plane. They depends upon the orientation of plane. The tensor quantities, when you apply mathematics to it, you will have to use matrices. Okay, there is one topic in mathematics, matrix. Okay, you don't have to. You just delete it in your mind. Don't worry. Don't worry. That doesn't concern you. You are not a researcher right now. Just focus on this. Okay. So what is going to be? So as I was saying, see, vectors know this thing. Vector have magnitude, it has direction, and also something which is having the direction is not necessarily a vector. Are you getting my point? The third condition which many students, many teachers forget, that vector is something that must obey the vector law of addition. Are you getting my point? vector law of addition. Okay, so the quantities which have magnitude, which have direction, and which obeys the vector law of addition, then they call as a vector. If any quantity having the direction but not obeying the vector law of addition, that means that it is not a vector quantity like current. Current doesn't obey vector law of addition. Are you getting my point? Are you getting my point? So, sir, is it obeying the vector law of subtraction? Or there is nothing like vector law of subtraction. It is always the vector law of addition. Understood, I think. Now, please understand this. This is going to be this. So, if I ask you the direction here, because we know displacement is a vector, so how would you be representing the direction of something? So we would be representing by the angle of it from some reference. So if I take this reference, this is theta. So what is going to be the angle to it? So you would say, sir, it is very easy. We can write tan theta, that is perpendicular upon base. So 2r upon pi r. So tan theta is equal to 2 by pi. So you can say that theta is equal to tan inverse 2 by pi. We know na theta is equal. Sir, from where we'll get the value of tan inverse 2 by pi? Don't worry, this is your answer. Okay, you can't get it other than the calculator. Okay, if you don't have the calculator, the scientific one, okay, you cannot answer this. All right. Okay. Okay. So guys, in this session, I'll keep it to this session in this particular session. So in this session, we have sorted out, we have understood the distance and displacement. Okay. Okay. So we'll be moving forward from here in the session, and after this session, distance and displacement thing might be clear to you, so you can pick up many question, as many as possible like these. Okay. And you can solve them. Okay, so I hope you have clearly understood the difference between distance and displacement. We have developed one standard, we have seen few questions also, and we have developed one standard way of solving one particular type of question. Okay, and like this simple question I'm not going to discuss here. So if someone has moved 5 meter east, then 5 meter north, what is going to be the displacement? If I say someone moves 4 meter east, then 3 meter west, 3 meter north. What is going to be the distance? Distance is 4 plus 3, that is 7. And what is the displacement? Displacement is going to be the shorter distance by Pythagoras theorem, that is 5 meters. Right? Someone moves in northeast direction, then it comes back in the south direction. Like those things you can do. Okay. Okay. So the things that requires your mode of attention, that I have done. So we have seen to some extent, like these questions are very much our rotation wala. Okay, so one has started from one point, followed the curve, semicircular curve, and then it reaches to the very bottom. What is the displacement? It followed quarter circle. Okay, it followed this, that. Under those cases, what is to be done? I hope that is to be clear to you. And moreover, this question is very important. Okay, so please read the question. Please try to think. So see, all you have to, my advice from the distance and displacement thing is, my advice is that you think that what is the initial and what is the final position, right? Try to formulate it, try to draw the figure, maybe in your mind sometimes in the small question, and you can go with the answer. Okay, like this question. Okay, okay. So see, it is basically very simple. You have to know some geometry. You have to be able to apply simple trigonometric ratio, Pythagoras theorem, simple vector addition, right? That will be all. So distance displacement is done. In the next session, we'll be continuing from this point. I may come up with a mathematical tool, or I may come up with the speed and average speed concept. See, instantaneous speed, instantaneous velocity concept you cannot understand until you know something of differentiation. Okay, so in this chapter we have graphs to go, like what is the displacement time graph, what is the velocity time, acceleration time. So all these graphs, how to make the graph, how to go from one graph to another graph. These all discussions can be made only when you understand some mathematical tools. So the next session I may come up with the mathematical tools, or I may come up with the average velocity or average speed concept. Okay. Okay, so for that you have to subscribe the channel so that you get the notification of every video. We already have completed one chapter very quickly, and now we are starting this next chapter, and I'm planning to finish this chapter within this week only. Okay, this is not a that big a chapter. Okay, so stay tuned. Please subscribe the channel. Please do like the videos. Please share to your friends so everyone can be benefited. And with this, thank you very much. Have a good day, and we'll see you in the next session with some new concepts and new understanding of physics.